Good morning, dear students. Today we will start the numerical portion of chapter 8, motion. Okay, till now we have done the theoretical portion as well as we did some questions also. So today we will do some numerical. Let's move further. You can see the statement is given there. Tortoise moves a distance of 100 meter in 15 minutes. What is the average speed of tortoise in kilometer per hour? So you need to do conversion also first. Convert a distance 100 meter into kilometer and then time into hour. So divide it by 60 for converting it into hour. And now the average speed will be total distance covered upon total time taken. Okay, just put the values and do the solution. Then the speed will be 0.4 kilometer per hour. Next question. If a sprinter runs a distance of 100 meter in 9.83 seconds, calculate his average speed in kilometer per hour. Okay, again do the conversions and put all the values and then try to solve them. Okay, so use these values. Average speed meter per second, it is the value is 100 upon 9.83. It comes 10.173 meter per second. Now we can convert it into kilometer per hour as divide it by 1000 and multiply it by 3600. Okay, then the value will be 36.62 kilometer per hour. Got it? Now the next question. This question is of your NCRT book also. A motorcyclist drive up from a place A to B with uniform speed 30 km per hour and returns from B to A with the speed of 20 km per hour. Find his average speed. Okay, so solution will be you have to find the average velocity of the entire journey. For this we have the following information. Speed A to B, it is V1 30 kilometer per second, kilometer per hour it is. Okay, and then let the distance A to B will be the D, and the time taken from A to B will be T1. Okay, then there's time will be equal to distance travel upon speed. T1 is equal to D upon 30. Speed from B to A, it is 20 kilometer per hour. Do the correction. It is not meter per second, it is kilometer per hour. Let the time taken will be T2. So T2 is equal to D upon 20. In the similar way, it is T1 is equal to D upon 30. Total time of journey is T1 plus T2. And solve this, it value becomes D upon 12. The total distance from A to B and B to A, it is 2D. Average speed is total distance travel upon total time taken. So on putting the values to obtain the average speed of the motorcyclist, we get it is 2D upon D by 12. 12 will move upward. D to D cancel out. Okay, it is 24 km per hour. Got it? Very important question for exam point of view also. Now next question. A motorcyclist starts from the rest and reaches a speed of 6 meter per second after traveling with a uniform acceleration for 3 seconds. Okay, what is his acceleration? Initial velocity will be 0 starting from the rest. Okay, final velocity 6 meter per second. Time taken, it is 3 seconds. Acceleration is A is equal to V minus U by T. Put all the values, then it becomes 2 meter per second square. Okay, next is an aircraft traveling at a 600 km per hour accelerates steadily at 10 km per hour per second, taking the speed of sound as 1100 km per hour at the aircraft's altitude. How long it will take to reach the sound barrier? Okay, final velocity given there, convert it into meter per second. Initial velocity again convert it into meter per second. Acceleration given there, convert it into meter per second. Okay, so the time taken will be equal to V is equal to U plus AT. T will be equal to V minus U by A. It becomes 50 seconds in around approximately. Okay, if a bus is traveling at 20 meter per second is subjected to a steady deceleration of 5 meter per second square, how long will it take to come to rest? Okay, we need to calculate time again. We have to find out the time taken. So initial velocity given there, finally it will come to rest, 0 it will be. Acceleration -5 because it is decreasing with the speed, and it is also known as retardation, -5 meter per second square. So the time taken by will be t. We can calculate the time taken using the first equation. T is equal to v minus u by a. It is 0 minus 20 upon 5, it is 4 second. Got it? Let's move further. Okay, so another question. A car is moving along a straight road at a steady speed. It travels 150 meter in 5 seconds. What is his average speed? Average speed is same. Total distance travel upon total time taken, 30 meter per second. How far does it travel in 1 second, 6 seconds? How long does it take to travel 240 meter? Okay, in 1 second it is 30, in 6 seconds into 6, 180. And distance is given there, speed is given there. You can find out the time, it is 8 seconds it will take. Okay, next question. A particle is moving in a circular path of radius r. The displacement after half a circle would be, your options are given there. Option C will be the right answer. Displacement is difference between final and the initial position of a body, its velocity. It's a vector quantity and independent of the path taken. So far the movement of half of a circle, the displacement is 2r, where r is the radius of the circular path. Okay, r is the radius of the circular path. Okay, got it? So it is 2r. Okay, and the speed of a moving object is determined to be this one. This speed is equal to, you need to convert it into kilometer per hour. Do the calculations. Okay, put all the values, then we will solve out. Then the option C will be the right answer. It is 0.216 kilometer per hour. Next question, 47 it is. A freely falling object travels 4.9 meter in first second and 4.72 meter in 6 second and third second and so on. This data shows that the motion is of a freely falling object in is a case of. Option C you can options you can see. Then the find out the right answer is B. The displacement of the body is equal equal in interval of time is unequal. So but the acceleration is constant, the acceleration will thus be uniform. So the answer is B, uniform acceleration. Okay, next question. See this. Which of the following can be sometimes be zero for a moving body? Average velocity, distance traveled, average speed, only displacement, only four. Okay, it will be average speed. The distance is the length of actual path covered by a moving body. This implies that the distance traveled by a moving body and also its average speed can never be zero at any point of time. However, it is possible for the displacement as well as the average velocity for the body to be zero at any instance during the motion of the particle. Next question. When a car driver traveling at a speed of 10 meter per second applies brakes and brings the car to rest in 20 seconds, then the retardation will be, find out its value, very easy. Find out the value of acceleration over there, then it is 0.5 meter per second square retardation. Okay, minus sign shows its value is decreasing acceleration it is. Okay, so d is equal to 0.5 meter per second square. Next is, which of the following would not be the unit of acceleration? Which it can be kilometer per second square, centimeter per second square, kilometer per second. Definitely it cannot be, because acceleration is meter per second square or kilometer per seconds will be square. Okay, rate of change of velocity. Next question. A body is moving along a circular path of radius r. What will be the distance traveled and displacement of the body when it completes half a revolution? We have to analyze the distance and displacement of a body that has covered half the perimeter of a circle. The distance traveled in half a rotation of a circular path is equal to the circumference of the semicircle. The distance traveled is equal to pi r. The displacement is calculated from the initial and the final position of the body. It is independent of the path covered, so the displacement is the diameter of the semicircle, hence displacement is 2r, where r is the radius of the circular path. Got it? Draw a circle and then try to understand this having radius r. Okay, what will be the distance traveled and displacement when it completes half a revolution? Half will be first, it will be its initial position at A, and at point another point exactly half, it will be in opposite direction, it is at another point. Okay, so the displacement will be 2r, double of the radius. Next is, if on a round trip you travel 6 kilometers and then arrive back home, okay, what distance you have traveled, what is your final displacement? Distance will be the actual path covered, so distance is equal, this total distance covered in this case due going to come back is 2d is equal to 6 kilometer. Okay, the d is the one-sided journey of the, okay, displacement is calculated from the initial and the final position. Distance is covered, displacement is calculated from the initial and the final position of a body. It is independent of the path covered, so the displacement in this case is 0 because the initial and final position are same. Okay, let's move to next question. Okay, let's move to next question. A body travels a distance of 3 km towards east and then 4 km towards north and finally 9 km towards east. So what is the total distance traveled and what is the resultant displacement? Okay, let's try to find out this. Then first is distance traveled in is the actual path covered. The total distance will be 3 plus 4 plus 9, it is 16 kilometer, and then the displacement will be equal to the body travels a total distance of 12 kilometer east, which means that towards the x-axis on a Cartesian plane it travels a distance of 4 kilometer in north direction, which means towards y-axis. So the resultant displacement is 12 square plus 4 square under the root, it is 160 under the root 12.65 kilometer. Okay. Okay, dear students, let's move to the next question. A boy walks from his classroom to the bookshop along a straight corridor towards north. He covers a distance of 20 meter in 25 seconds to reach the bookshop. After buying a book, he travels the same distance in the same time to reach back in the classroom. Find average speed, average velocity of the boy. So let's discuss the solution. The distance traveled is the length of the actual path covered. The total distance covered in going and coming back is, we all know it is given there, that is 20 plus 20, it is 40 meter, and the time taken is 25 seconds plus 25 seconds. So we can calculate the average speed as total distance traveled plus upon, not plus, upon total time taken 40 upon 50, it is 0.8 meter per second. Now the average velocity is 0, as the displacement is 0, because the boy arrives at the initial point. Okay, we all know the displacement is the difference between final and the initial point. Finally the boy is at his home and initially he was at his home. So in this particular case the average velocity is 0 because the net displacement is 0. Got it? Let's move further. Okay, now a ball hits a wall horizontally at 6 meter per second. Okay, what is given there? It is initial velocity u. It rebounds horizontally at 4.4 meter per second. The ball is in contact with the wall for for 0.040 second. What is the acceleration of the ball? Okay, what we need to find out? We need to calculate its acceleration. We are given with two values. One is initial velocity and final velocity, both are given there, and time is also given there. So we have to find out the value of uniform acceleration. For that we are given with initial velocity u 6 meter per second, final velocity in opposite direction to that of the initial velocity. The key point you need to note here is initial velocity is, its final velocity is, okay, both are shown over there by initial velocity. We all know u is the initial velocity and v is the final velocity in opposite direction. That's why minus sign is used over there. So the time taken is 0.04 second. Acceleration a is equal to v minus u upon t, to v minus u by t. Put the values in the above equation to get the values. Minus 4.4 minus 6, it is 10.4, it is 10.4. so upon 0.4, its value becomes minus 260 meter per second square. Minus sign shows the retardation, negative acceleration we also call this. Okay, let's move further. Okay, dear students, do all these questions in your notebook. Got it? This will definitely provides you a more better understanding of this chapter. So we completes this chapter. We have already discussed its theory portion. We already discussed some questions also related to this, and in this particular video we discussed about the numerical portion. Okay, thank you so much. For any query, any doubt, you can ask me on my personal account or you can call me. Got it? Thank you so much, boys, girls. Take care. Thank you. Have a good day. Enjoy your day.